The Build Show Build Boston series is sponsored by Alora Fiber Cement Siding, Mitsubishi Electric Train US, Roseburg, Schuco USA, and Warmboard.
Hey everybody. So I think before we can get talking about plans specifically, that we should do maybe a quick little class where we just talk about what is a plan set? How do you set up a plan set? What is an architect thinking about when they're putting a set of plans together? How do they number them? How to make sense of all of this, right? Yeah, we have this beautiful house. We have all of these ideas. We put it on paper, but what does it really mean and what are we trying to do? So, first thing, the reason for being. Obviously, the plans have all the dimensions and associated construction details for the house. But what it really is basically a language that I share with the contractors, in that I put down information on here. Some of it might be abbreviated. There might be, some real quick names or slang names to things that maybe we only interpret as the builder and the architect. But nonetheless, it's a language that we share, in that what I'm trying to do is show them the intent of the building that then they have to interpret as the building, right? And then execute it in the means and methods that are provided by them to put the building together. So the drawings aren't really there to show the builder how to build it. They're there to show the builder the intent of what we expect to be built. How they do it is the responsibility of the builder, meaning the means and methods. It's that language of interpretation that we share, that I need to understand the language because I'm the one authoring the story. The builder is the one that is reading the story and interpreting the story. So we both share that in common. So how do we lay out a set of drawings? Well, obviously we have the title sheet. We have a list of the drawings here. And so far in the drawing set, we have these drawings. Now, there's a number of ways. You could just simply sequentially layer the drawings or number the drawings, sheet A1, A2, A3, A4, A5, A6, blah, 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 all the way through A30 or whatever the drawing set will be. For smaller projects, I don't find that a problem. And when I say smaller projects, I mean up to about an 8, maybe 10 sheeter. Once I exceed 10 sheets, and which is pretty much every custom home, then I move into a different nomenclature as far as the numbering system. So you can see that the plans are any number between 0 and 10. The numbers in the tens, meaning 10 through 20, are building elevations. Numbers 20 through 30 are framing plans, foundation plan, roof framing plans, roof plan. So it is all the plans that are beyond the floor plan. 30s are building sections. 40s are details, wall section details, etc. And then 50s are typically interior elevations. Now, why would I do that in this kind of series of 10? Well, as we develop this drawing, right, if for some reason I say we make some changes and we need to develop another building elevation sheet, well, if we have them sequentially numbered and the building elevations are sheets A12, 13, and A14, and the drawing set goes up to A30, and I insert it, then I have to go through and I have to change all the numbers of the subsequent drawings all the time. Ask me how I know, right? 30 years of experience will help you develop some little tidbits of things to dodge some of those problems. So, and this is something that a lot of commercial architecture firms use. They have a numbering system of their own. This one is obviously smaller scale because it's only a custom residence. But this allows me to come in and say, okay, if I need to develop an additional building section, well, I don't have to renumber any of the sheets. I can just come in and add it as sheet A36, and then that becomes building section GG, and it gets inserted, and my drawing list doesn't change other than the simple addition of that number. So it's a real easy tool to use so that I don't get caught into this heavy manipulation of drawing numbers and sheets. So as we move on, right, we're just going to do a really quick overview because throughout the series, we're going to get into some pretty in-depth talking about specific building sections, details, and all of that. But, you know, floor plans, you can see this one here. The entire floor plan does fit on a sheet. Sheets are 24 by 36 inch. Those are D-size sheets. Drawings, floor plans are typically drawn to 1/4 inch scale. Now, what does 1/4 inch scale mean, right? You're familiar with an architectural scale. Most of the time they're triangular in nature, and they have a whole series of different scales. This one here, the 1/4 inch, is down this side. It's read right to left. And basically 1/4 inch scale simply means that for every 1/4 of an inch of paper space, meaning space on the paper, it equals 1 foot of actual space. So at 1/4 inch scale, the house or the plans are basically at 1/48th scale of the actual building, right? So if I took this plan and multiplied it 48 times, I would get to the size of the actual house, right? Another way to look at it. As we go up in detail, the scale changes and becomes larger because we need to see a little bit more of the building. The 1/4 inch scale, we're just basically looking for the wall layout, the layout of the rooms, the location of the windows, the sinks, toilets, all of that information, which can be handled by the dimensions at 1/4 inch scale. So floor plan, and in this case here, the first floor plan is the first one we show because that's probably the sheet that gets referenced the most in the drawing set. We move on. We talked about this sheet here. This is the basement floor plan. And they all have a title. They all have a marking as to what scale they were plotted at. Now, not what they were drawn at, it's what they were plotted at. If I go to, let's just bring it up here, for example, and I look at some of these dimensions, if I measure from there to there in the CAD file, it's actually 7 feet. On the CAD drawing, the thought is you draw to real space and you plot to scale. So everything that you're seeing on the screen here, this is basically the drawing set here of all the floor plans, framing plans, building elevations, building sections, all of that stuff. This is all drawn true to life. It gets scaled in the drawing when we send it to the print shop, when I create the actual layout of the paper space. If I switch here, you'll see, I'll give you a good example. If I go from model space, which is where things are actually drawn to real space, and click on that little tab, it'll bring up the floor plan, and you'll see that the floor plan is actually laid out on the sheet, the drawing sheet, like it's laid out here. So this now, if I measured something, it would be simply like measuring it on this piece of paper because that's being illustrated in what we term paper space, right? But if we go back to model space, that's actually building the building to real scale. And, you know, I never lie in my drawings. Lying will get you in trouble. It gets you in trouble in real life. It'll get you in more trouble in architectural drawing. So the beauty of drawing in real space is that a builder can call me when something is under construction and say, hey, I don't know if we have this dimension, but I need this from this point to that point. I can go right to the real space and I can give them what that distance is. We can pick a point over here on the slab or partially up the wall or at a windowsill or something, and then pick a point over here, and I could tell you what the difference is in elevation that they might not be able to get on site. So by drawing to real space allows me to answer those questions with a very definitive answer because nothing in those drawings are a lie. They're all drawn to actual real space. Moving on through the set of drawings here, we have the building elevations. And the building elevations, we have some cladding types on there. We have the window elevations. You can see all the window elevations here are drawn on this sheet. They're all basically the unit dimension. Now, one of the interesting things about, say, the elevation page is when you get this information, it's not information only for the builder. This information went to our window supplier, and now they know every one of these windows. Let's, pick windows 3, 4, 5, and 6. They have window tags, and you can see them located there, windows 3, 4, 5, and 6. If I go back to the floor plan here, you'll notice windows 3, 4, 5, and 6. They're tagged there in plan, and they're tagged here in elevation, and then they're given their unit dimension sizes, but they're also shown here as a fixed window, a tilt turn, and a fixed, and it shows the direction of operation for each of the sashes that are operable, and you can see that in elevation. So it might look like, oh, those are just the windows in the wall, but they're actually revealing an awful lot of information. They're fully coordinated across the spectrum of the drawings, and they're not only for the architect or the builder's use. These are going out to manufacturers and suppliers that are using this information to develop their estimate, their quotes, as well as their shop drawings and their list of the windows that we're going to build for the project. And just more, I like to put the window elevations on every sheet so guys don't have to flip back and forth out at the job site. It might take an extra sheet or two, but having the full window elevation schedule on every sheet of the elevations is very helpful to the gents out on the job site. It's really interesting. I spend a lot of time on the job site. I have a very high respect for the guys and gals that are out on the job site. They got a hard job to do. A lot of times up in New England, they're doing it on cold, rainy, snowy days. It's aggravating. I can't imagine doing that all the time. So, I'm always thinking about things like, how is it that I can put something on paper that can help them out, make their job a little easier, basically just help them out. So that's always in the back of my mind. More elevations. Now, this one here is pretty interesting. This is an elevation where we actually have a section of the building that is perpendicular to it, right? So this part of the elevation doesn't really exist. That part of the elevation is way out here in the foreground. So I dash in the section, but it's these other hidden elevation points that's happening behind what's in front that is important. So we needed to show the door, the cladding type, how the roofs, making sure that this sloped roof isn't in conflict with the flat roof, and making sure that a lot of these things are, worked out. So I'm working them out for construction so that the builder can understand it, but I'm also working them out to just ensure that my design is a successful one and actually works. There's a lot of times I get builders say, hey, I know you have this in the drawings, but I was thinking maybe we could do it this way. I'm always up for changes. I'm always up for the discussion on doing it a slightly different way. But what I will tell you is when the drawings leave my office, they leave the office with at least a solution to get built and a stepping point to have that conversation. So definitely up for it, but I don't think a set of drawings should ever leave an office without the idea of how are we going to build that, right? And I do hear some horror stories a lot that, I get these drawings and they just said, you can figure it out on the job site. Well, again, if you're on the coast of Massachusetts, it's mid-November, the wind is howling, and you have to carry plywood and all this stuff around up there. That's not the time to be figuring stuff out, right? That's the time to just be doing, because the stuff should be figured out. So, onward and upward. Another sheet of elevation there. And then we move on to the foundation and framing plans. So you can see here, preliminary foundation plan, and we basically have the outline. We have all the dimensions, all the interior footings are coordinated with the columns and the structural framing plans, and how all that stuff gets put together. Our light well here that we'll just pour as the 8-foot well, and then we'll just backfill it to what we need it to be. We have the stairwell here that goes down from the garage. All the garage door openings are dimensioned. Any footings that we need to place on the outside for our decks and spaces out there, those are all out there. So, foundation plan. And like I said, this is just a quick overview. We're going to dive into this stuff hot and heavy when we get into it. Just a really quick section. Here's a section showing that stairway down to the garage and some of the elevations so that the builder knows, you know, hey, what are we talking about? How tall is that? How deep does this go? And then some associated details, some of the pier details. I always typically do a typical foundation wall detail with the foundation plan so that the foundation guy, he doesn't need to go through and know all about what kind of siding and what does the roof look like. Foundation guy cares about the foundation. So I give him a foundation drawing. It has the rebar in there. It has the drainage and everything that's going to happen associated with that floor plan or that wall, foundation wall of the basement. And we put that there, and I strip out all of the other information. So, you know, one of the things that I've learned too is that, you know, some architects like to, I use the word clutter, I'll just use it loosely, but clutter drawings up. I like to give the information that is needed by the person that's going to be interpreting that drawing, right? The siding guy is never looking at this drawing. The electrician is never looking at this drawing. The only person that really cares about this drawing is probably the excavator and the foundation guy. And so it's with the foundation plan. All the other information is stripped out. Only the information that the foundation guy needs and the information that the maybe the site excavator will need. So, you know, something I've learned. And it keeps me out of trouble because if they have to decipher more information, there's more of a chance for error. If I give them just the information that they need, then there's less chance for error because they're not interpreting as much information. They're just interpreting the information that they need. So keep that in mind for all you young architects that are out there thinking about, hey, how do I develop a set of drawings? All right. Floor framing plan. Again, sometimes you just see these as simple lines. I like to draw out the thickness of every floor joist. I like to draw all the solid blocking. I like to put the beams in. I like to put the column locations in. I like a fully coordinated set because, like I said, they don't leave my office until I understand how to put the whole house together. And that's every detail. I can walk through and I can pull a dimension for everything from how the front stoop is dimensioned and how it's put together and what size ledger is hanging off the wall to what size these beams are, etc. I send all of this information. I put it together. I do an initial sizing on all the beams, and then I send it to my structural engineer. He does a full comprehensive review, but he's basically either putting a check mark here or he's crossing that out and writing in the new size of the beam that it should be. Sometimes these beams are a little larger than maybe what they need to be, and he says, hey, these can get away with doing them at this size, and he'll put that note in there. But that's how I work with my structural engineer. This is the roof framing plan. You can see here. Now, these are all the sloped roofs, and you can see we have this one over the main area, this one over the owner's suite, and then this is the roof area over the garage. There's a couple beams there. This one we chose to frame conventionally, so that's just a whole series of 2x12s, 16-inch on center. These two roofs are going to be trussed roofs, and you can see that I drew the truss profile here for that roof and the truss profile B here for this roof, truss type B. And basically what I'm showing there is what is my intent on the truss profile, right? What are the slopes? What does that look like? These are going to both have interior slopes to them, and then we'll have some space for insulation. And what are the overhangs? What is it getting cut back to, trimmed back to for the framer? So again, I have this idea of this is how I put it together. I throw it on the paper, we send it off, and that's how the guys interpret it. As far as headers go, I create a header schedule here, and you see headers A, B, C, all the way through H12. And if I go out to the drawings here, you'll see that, hey, there's header B, header A for those windows, header A, header B, A. So they just simply look header B and they reference it, go over here to the legend, and they know exactly what header is being placed in there. And again, that's on the same page. So we're not shifting through all these pages when these guys are doing the layout for that. This is the layout for what I call the lower roof or the flat roof plan. So these are those series of flat roofs where we have over the utility section, over the 2 bedrooms, over this connector piece, the front entry, and of course the bathroom. And then we have those 3 slope sections that we just looked at. Again, the legend for the headers is also on this page. So as we pick up the different headers and header locations, we can reference that and know exactly what the makeup is for each of the headers. This is the roof plan. And on the roof plan, you notice it shows where we have the standing seam metal, where we have the flat roof. It's a tapered membrane roof, so we'll have tapered insulation so you can see where the high points, the valleys are, where I'm intentionally showing the slopes. But you can also notice I put where the gutters are going to go and where the downspout locations are, where they breach the roof and where they are on the wall. So I have that all preliminary laid out. Like I said, again, we might go out to the job site and after this is framed, we might say, hey, can we move that gutter over, move it around the corner and all of that. But before you build it, we need to know what's going on there, and we at least need to know what the initial thoughts and intent are so that we can have a discussion about it. Everything's subject to change, but we need to start somewhere, and we need that somewhere to be on the paper. So that's it for the Series 20 drawings. Moving into the Series 30, you can see we have our building sections. And, the building sections just give you some assembly writing here where it basically just we'll talk about what's happening from the outside of the wall through the inside of the wall, all the different aspects. We're going to have details of all of these specific areas cut out, and we'll have those finely dimensioned and tuned with exactly what materials we're going to be using in those spaces. But the building section gives you a general sense of what's happening, and this is where we find the vertical dimensions, right? The floor plan gives us the horizontal dimensions, but the building sections give us the vertical dimensions. And these are at 1/2 inch scale. So these are 1/24 the size of the actual house. So if I expanded this image 24x, I would have the actual size of the building section. And those of you not quite familiar with what a building section is, say building section AA, if we go back to the original plan here, you'll see it says section AA. On the section line, there's an arrow that points to the left. So basically what that's saying is if I took a giant knife, sliced it through the building, pulled this section away, it would reveal a building section here looking to my left, and it would look like that. Going through here, there's a series of more building sections, and like I say, we'll dive into this stuff a little deeper later on. Now, sometimes we can't get the building section all on one sheet at 24 or 1/2 inch scale, 1/24. So notice here, building section FF, and it's the right side. So basically what I've done is I've split that building section. So we'll have a little overlap of information here in the middle that you can see here. There's that door and the beginning of the stairway. There's that door and the beginning of the stairway. But this shows all the information on the right-hand side. This shows all the information on the left-hand side. And then lastly here in this set, we have our initial electrical plan. So basically, it's showing switch locations, lighting locations where fans are, drop lights, recessed lights, surface mount fixtures, wall mounted fixtures, exterior outlets, all of that stuff. And again, when we're out there and the house is built, we're going to walk through the house with the client. We're going to go to every room and say, okay, we're in the dining area. This was the plan. We have a dropped light here. We have recessed lights that are happening around the perimeter. We have outlets there, there, and there. Is there anything you want to change? And now that you see the house in true 3D because it's framed, sometimes we'll sit there and say, well, let's slide that outlet down and add another one, or we can eliminate that outlet, or let's get rid of those lights and I just want, 3 in a row here or something. So things are subject to change. As the building's getting built, I'm still working with the clients and we're working on some interior finishes and stuff like that. So things, again, are subject to change. The importance of things like the electrical plan is that the electrician is binding a contract with the general contractor that suggests, I'm going to do this, right? There's 5 fans, there's 62 recess cans, there's 148 outlets, et cetera, et cetera. Those might not be the numbers. I'm just throwing them out there. But there's something that binds the contract and the scope of work between the subcontractor and the general contractor. And the general contractor then uses that information to bind the contract with the client. So again, this information is to show the intent of what we want to do electrically, and then we'll adjust from there. And then, of course, we have the lower floor here. And then lastly, we have the site plan. Now, this is on an engineering scale. This is where 1 inch equals 30 feet because we obviously have to get a much larger square footage in. But you can see here, the red lines are showing where the old house is. And then we have the driveway that comes up that we said we were going to use and kind of come across the front of the house because the garages are over here. But you can see where the front of the existing house is on that plane, and now we've rotated it to that plane. So you can see that we've made that adjustment there so that the south-facing roof becomes almost true south-facing instead of leaving it on that angle and being slightly off. That helps improve and optimize our solar access for our PV array located on the top of the garage. Anyways, that's a quick overview on what a drawing set looks like, what are some of the reasons for the plan, some of the information that's in there. Like I said, as we go through the construction of the project and all the episodes, we're going to return to the drawing set as common practice, and we're going to talk about the details and all of the pieces that have come together to put that house together.